So hi again. Now we're going to talk more about the binary addition and subtraction. So let's start with addition. It's something that I covered in the last video, but it's still important to go into detail of what the binary addition looks like. This will become important later on when we're actually creating circuits that are adders. We want to corroborate that those circuits are performing functions that we want them to perform. So, it's good to know this, to have the skill. So, I feel like the best way to learn addition is just with examples and jumping right to it. So let's start with this example of 10111 plus 110101. So let me just write that. Okay, so here is our written example. You want to make sure, just like in regular addition, that you are lining them up according to the least significant bit. And so we will start. This example we've covered in the last video. It's going to be 1 plus 1, which is 2. 2 is a value that one single digit cannot have in binary, so we see that 2 is equal to 1, 0, so we're going to carry this 1. We will write 0 and then carry a 1 to add to the next value for the next digit. So again, we have 1 plus 1 plus 0. It's going to be the exact same process. We're going to carry a 1 towards the next value. And now this is a new scenario that we've encountered. We're going to have 3 1s. So it's going to be 1 plus 1 plus 1, which is going to equal 3. So we're going to do the same process as we did with 2. We know that 2 is 1, 0, and 3 is equal to 1, 1. So we are going to write the least significant bit in the answer slot, and we are going to carry the most significant bit. So we will carry it over here. That's something else that we needed to cover. So now that we've carried the most significant bit, we'll add 1 plus 0 plus 0, which is 1, and then 1 plus 1, which is again going to equal 2, so 0, carry a 1, and then we will again add 1 plus 1, which is 0, carry a 1, and then the 1 just drops down to 1. So this is basically what addition is. You won't find any problem more complicated than this because it's just a simple sequence of steps to follow. What I do want to show you is how to corroborate your result. And to corroborate your result, it is very easy. You're just going to need to convert these numbers into decimal. And then add those decimal numbers and see if it gives you the same result as this binary number. I have the numbers. You can go over the video on how to convert from binary to decimal to corroborate my answers and to do it yourself. So this number will be 23 plus 53, and this gives us 76. And this is, in fact, if we convert 76 to binary, or this number in binary to 76, we will see that it is, in fact, the same number. So this is correct. Just a cool trick to kind of corroborate your answers, make sure that you're doing it correctly, and have confidence in your answer. So now we're going to go over subtraction. For subtraction, we're going to start off with a very simple example. There are 2 ways to subtract in binary. One is regular subtraction, and then the second is adding the 2's complement. So let's start with regular subtraction. The process will be very similar to what we know how to do by hand. So let me write out the problem. And let's see what these numbers are in decimal. In decimal, these will be 6 minus 3. So this would give us 3. So we need the answer of 3 to make sure that we're doing it correctly. So let's start with the least significant bit. This is where it can get complicated when you're subtracting 1 from 0. You're going to have to borrow from the other digit a 2. So just like when we're subtracting in decimal, we would borrow a 10, here we're borrowing a 2. So now this number will become 1, 0 minus 1. So that's important to remember. It's not like you borrow a 1 and then this becomes 0, by the way. And this becomes 0 and this becomes 1 and this will be 0. You're actually doing 2 minus 1, which will become 1. Now that this digit has given its value to the previous digit, we're going to have to do the same exact process. So we will make this one a 0 and it will give a 2 or a 1, 0 to the digit. And 2 minus 1 will again give us 1. And then finally we have 0 minus 0, which will give us 0. And this is in fact 3. So this is a process that will pretty much always work out, but it is very easy to make a mistake or to forget that this becomes a 2, so it is not the most useful process to know. That's why we're going to cover adding the 2's complement. I covered how to create the 2's complement in a previous video, so I'm just going to glance over it right now. We're going to do the same example. Let me just write it out again. So again we have 6 minus 3. So what we're going to do is convert whatever we're subtracting into its 2's complement. So let me just do that right here. So it's just going to be the zeros will turn into 1s and the 1s will turn into 0s and then plus 1. So we get 1, 0, 1. Now that we have the 2's complement, we're going to write a different equation for the addition. So let me just write that out. It is going to be 6 plus the 2's complement of 3, which is 1, 0, 1. So now that we have this, we can just add, and adding is much easier than subtracting. So 0 plus 1 will equal 1, 1 plus 0 also 1, and then 1 plus 1 will equal 2, so we put the 2 and we carry the 1, which will go down to here. Now, I'm sure you've noticed that we do have an extra digit. This is going to be the case most of the times. The only times when you can't do this is when you're subtracting a larger number than the number you are subtracting to. So let's say you wanted to do 3 minus 6. We are going to delete this last digit, and that gives us our answer of 3. So that is basically everything there is to addition and subtraction in binary. For the subtraction, of course, there are more complicated examples, and I do recommend covering them. But, you know, it's just a 2's complement, so as long as you're good with the 2's complement and adding, you're pretty much fine with subtraction.